Good afternoon, all. Welcome to the last session of our workshop series on spatial data analysis and mapping with Supermap Corporation Limited, China. The workshop series was conducted in relation to 8th International Conference of Sabargam University of Sri Lanka. Dear participants, kindly note that you will have to submit your assignments to the VLE system and winners will be rewarded after reviewing the assignments. Today's workshop consists of two main sessions. The first session will focus on network analysis and statistical analysis. The second session will be on 3D scene making and 3D spatial analysis. The session will be conducted by Ms. Kim. So dear madam, it's over to you.
Good day, everyone. This is Chin speaking. Wait a moment. Let me share my screen first. Good day, guys. Welcome to the Supermap GIS training, and this is the last training for this workshop. So, today's topic is about the network analysis and spatial statistic analysis, and also we are going to talk about this 3D modeling and 3D spatial analysis. Before today's course, let me review. Let's review the course we learned in the last course. In the last course, we learned about the spatial analysis, including the vector analysis and the raster analysis. In last course, I simply introduced the basic concepts of vector analysis and raster analysis, and then I demonstrate you how to use those analysis methods to the reality life, just like we made a precipitation distribution map by creating the Tyson polygon and by the interpolation. So here we can see this is the result of the spatial analysis which we made the precipitation area map of Thailand, and also this and also use interpolation to make a precipitation distribution map. So in this course, we are going to talk about the network analysis and spatial statistic analysis. This is the first section in today's course, network analysis and spatial statistic analysis. And in the second part, I will introduce this 3D modeling and 3D spatial analysis. So now let's go on our course. As same as the last course, I also introduce the basic concepts of network analysis and spatial statistic analysis. So the first part is network analysis. I think all of you have have the basic concepts of network analysis, since it widely used in our reality life, just like you often use digital map on your mobile phone. I think you usually use the road navigation or the land plan or the road plan, or you use your amp, the map amp, to find out the optimal paths. So this is all related with the network analysis. But in GIS side, there are two different models of network. There are transportation network model, which is just I mentioned about the road navigation, the road plan, and others related with the road network. And another one is about the vicinity network model, which is the vicinity network model is the network with directions, commonly including the petroleum or gas pipelines, rivers, and such like this. And all this network is a directed word network whose flowing directions decided by the sources and things in the network. Then let's take a look at the transportation network model which SuperMap provided. There are optimal path analysis, find the TSP paths, find the closest vicinities, and the service area analysis, and the find MTSP paths, allocate, location, and allocation analysis, which are all provided by the SuperMap. And what's more, SuperMap also provide the functions of dynamic segmentation, navigation, route plan, transfer analysis, and indoor navigation. So it is a powerful functions for your network transportation network analysis. And the vicinity network model, here we can see there are critical element analysis, connectivity between 2 points, single element tracing analysis, multiple element tracing analysis, and others. All these methods are used for the vicinities, just like the pipeline analysis and the rivers or other network with directions. So this is about the vicinity, the network analysis, and it is simple. So I just to simply introduce you what it includes in SuperMap GIS. And then I'd like to talk about the spatial statistic analysis. The first one for the spatial statistic analysis, we can create a diagram in SuperMap. We know that the diagram is a graphic representation that shows and main relations, distribution, trends, and patterns of data. We can create different types of diagrams to research relations of data and dig useful information, which the diagram are widely used in the big data fields to help you to dig the deeply information of the big data. And Supermap at desktop supports creating different types of diagram based on data attribute information. With Supermap at desktop, you can perform the following operators. Here lists the operators you can achieve by Supermap at desktop. And here we can just take a look at the example at the left side, at the right side, sorry. This map shows the traffic jam situation of Beijing in the morning rush hour. From the map, we can roughly know about where the hot areas and cold areas are. And to mine more information, we can also create several different types of diagrams to represent traffic jam situation. From these diagrams, we can get more specific information, which can help traffic administrative departments to make decisions on traffic improvements. So this is the diagram, and here shows the types of diagram which Supermap can provide. There are column chart, donut chart, line chart, combo diagram, and other, and have many types. And then I'd like to talk about the spatial statistic analysis. The spatial statistical analysis refers to the statistical method of analyzing geospatial data and researching spatial relationships. There are two aspects included by the spatial statistic analysis. They are statistical analysis of spatial data. The statistical analysis of the non-spatial characteristics of space objects and phenomena, and the central topic of settlement is how to describe a space phenomena in mathematical statistical method. And another one is spatial statistical analysis of data. It is directly from the spatial location of space objects content, study both random and structural or natural phenomena with spatial correlation and dependence. Its core is the understanding between data associated with the geographical position of spatial dependence, spatial correlation, and spatial autocorrelation. Build a statistical relationship between data by space position. Then the spatial statistical analysis provides a series of statistical functions for analyzing spatial distribution, pattern, process, and relationship. To analyze the spatial data and the related properties to determine the average center or the overall direction trend, identify statistical significant spatial clustering, such like the hot spots or the cold spots, and determine appropriate appropriate analysis skill and to explore the spatial relations. And the Supermap at desktop provides the following types of spatial statistical analysis. They are mirroring geographic analysis, analyzing patterns, cluster analysis, modeling spatial relationships. What we are use more here, and you can understand easily is the cluster analysis. It is to identify the hotspots, cold spots, or spatial outlines with statistical significance. And let's take a look at some cases. Just like the first one, it shows the analysis result map about predictions of logging in Weibo in Beijing. And the second example shows hotspot analysis for the number of calling 911 within an area. So here we can see the The red area is the hot spot, and the blue area is the cold spot. And here, all these areas are based on a parameter that's called the confidence level. And also the spatial statistical analysis can apply in for many fields such like the resource management, urban construction, and ecological and environmental assessments, and the regional economy. Just like for the urban construction, it can be used to analyze the urban population, economy, construction, and other dependent development changes, statistical change trend and change law, and the location of urban public facilities. So this is about the basic concepts of network analysis and the statistical analysis. The next we are going on the hands-on part. For the time limits, I only show you how spatial statistical analysis works in SuperMem at desktop. And for the network analysis, I have assigned this this work as an extension. So here, after our training, after our course, you can following the user manual to finish the network analysis. And after our training, I will share all the materials used in our course. So now let's just take a look at how to achieve the spatial statistical analysis. So this section mainly uses statistics analysis to achieve the analysis of the number of public service facilities to help us understand the number of existing public service facilities and help us make better decisions for the management of public service facilities. The data we are going to use including POI data and administrative data. The POI data you can download it from the OSM, just as I mentioned in the last course, how to download OSM data. And let's take a look at the workflow. Firstly, it also the data processing, and then do the statistic analysis, and then lay out the analysis result. Finally, make a result analysis. So here, let's take a look at this. When we open the POI data, it includes many, you can take a look at the table. It includes many attributes, and then we need to further process it, just like we need to associate it with city name, with cities, or with the province, and then we need to statistics, the number of the public service of the public facility services, just like the hospital, bank, hotel, restaurant, schools. We need to count the number of the facilities, and then we are going to do the statistical analysis by making diagram map or create the statistical diagrams. So here it shows the results of the analysis. This is make a diagram on the map. And also here we have another method to combine the semantic map and the
6 semester শুরু হলো সেইভাবে করে সেটা doing well ফাইজারের ইয়েও দিয়ে দিচ্ছে ওরা
So here is another way to represent the statistical results. We represent the result by create the range map and the dot semantic map. Here I will show you how to achieve this. And then let's go back to our desktop. Here, I already for saving the time. I imported the POIs in advance. So the data, while you download the OSM data and unzip it, here you can find the POI data. This one POIs. And then you can just import the shape file to the desktop. So here it is. And let's take a look at the attribute table of the POS. Here we can see there the POS ID and its code and the F class and the class. Here we can see there it includes many public facility services, just like hotel, restaurant, police, and others. So here we have many choices to select some of them to do the statistical analysis. And here is the facility, the public services facilities name. And here we are going to first end administrative data and to new map. You can statistic the provinces of the POIs or the public service facilities with the province, and also you can select one city to finish your analysis. Here I'm going to select one city to statistic its the number of public service facilities for each district. Here I'm going to statistic the Bangkok city. You can choose the whole cities, but for here you can see that there are more than 80. There are more than 89,000 data POI data. So if you use the whole area, if you analyze the whole area, it may takes more time. So for saving the time, I'm going to only choose one city's POI data to do the analysis. I'm choose the Bangkok city. Firstly, I select, so I don't know where the Bangkok city is, so I can select it, just back click it on the map. Just as I mentioned, this is about the simple query. Here we can check the properties, and the city is Bangkok city. And also you can use the circle query to to find out the Bangkok city and the city you want to analyze and save the result. So, and then actually, we are going to, and then we end the districts of the Bangkok city. So here we can also use circle query. Clear the previous conditions, and here we set the administrative to the name to. No, I think here we can also set name one equal Bangkok city. Front map. Remove this. Actually, we are going to analyze the whole Bangkok cities. So here we are going to use the district data of the Bangkok city. Here we can end the name of the Bangkok city by create the semantic map label. Here we can change the name at name 2. So here we can know the each city's name and change the near style. And then what the next we are going to do is to extract the POIs of Bangkok city. Here we can, and all the POI data in the maps. So here we can see there are too many POI data, and then the next we are going to extract the POI data only in the Bangkok city. So here we can use the we have several choices. We can use the spatial analysis, overlay analysis, and also we can use spatial query to query the POIs in the Bangkok city. Here, yeah. First, let me use this spatial query, and firstly we select the Bangkok city's boundary, and then spatial query. Here we check the POIs and the spatial query condition we select contain, and save the result. And the curve. So here we can see there are more than 14,000 data included by Bangkok city. And here let me remove the whole one and end the POI only included by Bangkok city. So here we finished this. And then what we are going to do is to statistic the number of each district. So here we can see the points located in the Bangkok city, and but let's take a look at the attributes table. There is no city or city. There is no cities or any district related fields in the attributes table. So here we are going to associate associate the POI with the city. So here we can associate POI with cities by adjust the spatial relationship. Here we can use the dataset attributes update method. Here, let me show you how to achieve this. Here we are going to find the data menu and their data processing. It provides running methods of data processing. We're going to the dataset attributes update. So here we want to add the city names to the POIs. So here we need to update the attributes tables fields. Then here we can see the data with attributes offered. The offered, we are going to select the Bangkok cities, and the target data, we want to renew the POIs of Bangkok city, and then here this one is the key parameters, the spatial relationships. Here we just select the contain, and then the source field, the target field. Here we are going to select the city names, also the city's ID to the target field. We new a field, and then let's click OK. So then and let me check the attribute table. So here we can see the POIs has already related with the Bangkok city's name, and let's check it. And to the count map, and then we can make a thematic map. Next, we can divide it by city names. So here we can easily to check the result. The POI has already divided by the cities. And then what we are going to do is to count the number of POI in each city. So here we can see in each city, we can just like in this city, every city includes many classes of public service facilities. So here we are going to select some of the public service public facilities to count the number of the facilities to get the statistical result. And what we are going to do is to let me think. Here we are also going to the data processing method, and then we are going to use the update field. Sorry, not this one. Also, let me think. Check the user manual. Count number of GPOI. Yeah. So here, we can just right click at the class fields and then summarize the field. Here the filter, we can select it. We can filter it by the city name. And oh no, the filter we are going to select the class. We select the class equal. Here we are going to select some of the public facilities services, like the bank. Okay, and here group by. Here we want to count the number of the POIs for each city. So here we group by the cities, and then POI statistic, we rename it as bank. Summarize field, here we can select the class. And let me check. Here there is a new table generated. Let's take a look at. Here we can see this is the statistical result of bank in each city. So here we can know how many banks in each city, and we can do the same with other POIs. We select F class. Here, name, I'm going to count the number of hospital. Okay, and group by, do the same. Okay, rename it as hospital. And summarize field, the class field. And let me do this, select some more POIs. Class equal to select restaurant. Okay. Name. Restaurant. And the summarize field as class. And let me connect one more. Sorry. Your name choose maybe school. Okay. For the time limits, I only show these 4 POIs, and you can select more POIs to count the number of it. And here we can check the result of each POI, and all these results are related with the cities. And then here we can see the tables in dependence. So here we want to relate the POIs with the cities. So the next we are going to update the POI numbers to city layer. Here we are going to use the firstly we are going to use the data processing append color. So here we select the city layer, Bangkok, and join field. We can select the city name and the source data. First need the bank and join field, which the join field should be the only the key. It is the key field to relate these two tables. So upon tables, here we can going to select the statistic count and the class. Okay. So here we can check the result. Here we can see the bank number has already updated to the city layer, and then we do the same for the rest POIs. Append color and to hospital. Okay. Restaurant, statistical count and the class. We must. Oh, I forgot to rename it. I think it is school. And then close it and open the attribute table again. We can see the school, restaurant, hospital, banks. The count have all updated to the city layer. Here, we need to do some processing. Is to change the field's name. So here we are going to the attribute structure. And let me new bank. Here the we change it type as here I think we can change it as int and hospital. And restaurant. Restaurant. And the school. And apply it. And then we are going to update the statistic count to the new fields. So we can either need to know what's the number of represents. So here we are going to right click at the fields and update field. Here we are going to select the first. Here we can see all these fields are the same so here we need to make them difference. Okay, right. And bank, hospital, we can do the same. The hospital is the second statistic count. Okay, right. And we're going to change the restaurant. The third statistic count. Okay. Okay. Maybe I select. Let me check. 1, 2, 3. Oh, I think the hospital is wrong. Let me renew it again. It should be the statistic count 1. Okay, apply it. So hospital, yeah, that's right. And the last one, school, which is the last one. Apply. So here we update the numbers to this field. And then here we can see there are some cities without this POS. So here we can update the field with 0. We first sort the fields and then update the fields with 0. Here we can see every city has restaurants, but some city is without the schools and the bank and the hospital. So then here we finish the count of the POS. What we are going to do is that we can going to make a map. Here, just as here well, you see here, we can just we can only represent map like this if we don't process the data. After we process the data, here let me remove it and it to the current map. And what we are going to do here, we can create thematic map, and here we can create graph map. Here we can select the type to statistic. Here we can design. And then here we can add the fields we are going to statistic. Okay. And then here we can change the color of the result. And what's more, we can label the number, the count number on the graph. So here we graph labels. We can see the value and change the label style, change the font of the label and the color of the label and the font size of the label. Like this. So here you can see we have finished the graph, a map, and the map is with the statistical information of the public facility services. And what we are going to do in the next is to make the result much more beautiful and much more meaningful here. And the next, before the layout, I'd like to demonstrate you how to create diagram. So here we can just right click at the city data, city data set, and then we can create columns. And here also provide many choices for you to count the number of the public facility services. And here we are going to also can add this bank, hospitals, restaurant, school. So here we can get the statistical information of the whole Bangkok city. And here we can also change the bank, hospital, restaurant, and also we can change the styles of each. The titles, we can change the title. Of Bangkok city. So here we can change and then we can do much more, and then we can save the result. So here, let me close the. And then, as I mentioned here, we can also combine two different semantic map to represent the statistical results. So here, just like here, this map is to show the bank statistics and the hospital, the hotel statistic result. So here we can also do like this. Just like we also create with just need this layer invisible, and let me show you how to combine the two semantic map to represent the results. Here we are going to create a range map, and then here we can change the bank number and also the color, any color you like, and also here we can set the changes, the ranges of the bank's number, and then here we can also create another semantic map like the graduated symbol, and here we can we also can change the expression as for the hospital. So here is the result combined by these two different semantic map, which can also represent the statistical result. And the next, what the next you are going to do is to lay out the results. So also for a time limit, I'm not going to show you the layout. Here, I already finished the layout. Here you can see. After you finish the map making, you can lay out the statistical result and output your results. So here is this one, and also the group statistic like this. And here you should add the legend and make the result meaningful is to change to make the value much more readable. And like this. So for this part, I only show this. So then after your after the result finished, you can describe the features of the public service facilities distribution of the city, and also put forward suggestions to improve the capabilities of public service facilities. Just like this result shows here, we can see there are many. There are more restaurants than any other public service facilities, and you can see it is reasonable since the Bangkok city is a tourism city, so there are more restaurants than others. So you can do the analysis such like this. And also you can put forward your suggestions to improve the building of public service facilities. And then here is the homework for you to complete public service facility statistic analysis and create at least one thematic map, and also complete the analysis of the results. So here is the network analysis. I wish you can finish it after our training. And then for the second part of today's work, we are going to talk about the 3D modeling and the 3D spatial analysis. I think we can have a 5 minutes break. So I'll see you later. Let's have a break. So welcome back. Let's continue our content. So the last part is about the 3D modeling and the 3D spatial analysis. Let me introduce the basic concept of 3D. In our SuperMap, we support multiple sources of 3D data, including the terrain data, oblique photography data, and the beam data, and also the laser point cloud data, and the manual model, water effect, underground pipeline, 3D fields, these types of data. And all this data can be integrated in one thing, just like here shows the oblique photography with the road, and the oblique photography will integrated with the terrain data, and also the oblique photography with the beam data, and the beam data integrated with terrain data. What's more, the 3D data can not only display on the SuperMap at desktop, but also you can do the further 3D spatial analysis, and also you can display the 3D scene on the web terminal, a mobile terminal, and just like you can display this 3D scene on the web terminal by WebGL, after publish the scene as 3D services, and also this 3D scene can be displayed on the mobile terminal, and also supports the VR, AR applications. Then the next, we are going to demonstrate how 3D applied in the iDesktop. There are two types of scenes in the iDesktop: plane scene and the spherical scene. The plane scene is that the surface of the Earth is spread out into a plane. It can only support planar and projected coordinate system. But the spherical scene simulates the surface of the Earth with a sphere, supports data of geographical and projected coordinate systems. And the 3D data managed by the 3D scene including the screen layer, general layer, terrain layer, and the screen layer manages the layer of static graphics such as the logo, descriptions, or pictures without the operations. And the general layer manages most
Right. So,
types
I don't know.
including this 2D data, 3D data, cached data, service layer. Almost all the layers are managed by the general layer, and the terrain layer only manages the DEM layer, terrain cache, and grid data. So now let's take a look at the steps of 3D modeling from the 2D vector data to this 3D model. Here, the first one is to load the 2D data to the scene and then set the bottom altitude and extension for the 2D vector data, and then add the texture to this extension models, and finally we can achieve the 2D data to this 3D model conversion. What's more, the 2D data can be also synchronized by 3D symbolization. Just like here shows the 2D data can be symbolized by the 3D tree symbols, and the 2D line can be symbolized by the 3D road symbols, and the polygons, 2D polygon can be symbolized by this 3D water effect. What's more, the dynamic layer are also supported to add to the scene, just like this example shows. After modeling, the supermap also provides a strong 3D spatial analysis methods, including including the variability analysis, shadow analysis, scanline analysis, openness analysis. What's more, it can be supports also much more 3D analysis, spatial analysis than you think. So now let's take a look at the hands-on part to know more about this 3D modeling and the 3D spatial analysis. Then let's take a look at the hands-on part. Also, this part is to transform the 2D vector data to 3D models by rapid modeling, and to help us create a 3D scene with supermap at desktop. And then we can do this 3D spatial analysis in the 3D scene. So the data we are going to use, including building data, road data, water data, and administrative data. The first 3 data you can find from the OSM data. And here is the workflow. First is also the data processing, and then 3D modeling, and then the 3D analysis. So here we can say we prepared the 2D vector data, and then do the 3D modeling from 2D to 3D, and then and textures to the models. Finally, we can achieve the 3D spatial analysis. And then let's go back to the desktop to take a look how 3D modeling works. Here, let me close this. And I mentioned that we need the building data, road data, and water data, and also administrative data. So all these buildings, roads, waters are from the OSM data. So here we can add those to a new map. since it takes time to import the buildings data to the desktop, so I imported those data in advance. Oh. So here we can see there are too many roads and buildings, waters in one country. So here we we're going to select one small area to do the 3D modeling, and you can select you can draw a small area to finish this 3D modeling, or you can select one community to complete this 3D modeling, or select one street or one district. So here I'm going to and to current maps this. So here I'm going to select one small district to do this 3D modeling. So I think this area is small enough. Maybe this. So here, firstly, we are going to extract the features in this area. As I mentioned, you can just draw an area or just select a community area to do the extraction. So here, firstly, I'm going to extract the buildings. Here, let's take a look at here. At the boundary, there are also many buildings, but we don't want to split them. So here we are going to use the spatial analysis, the spatial query. Going to do the buildings, and we can going to use the intersect. Building, receive the result. So here we can see the results have been finished, and the buildings at the boundary of the area that haven't been split. So, and then we are going to do the water. So here we need to split the water. Only we want to the water and the roads included by this area. So here we can use easy way. Here we are going to can find the maps and map clip. Select object area clip. Here we can just keep the layers we want to clip. The roads and water, and here we name it roads, water, and okay. So here we can see that we can get the results only included by this area. So there are many choices for you to finish the operation. It's up to you, and only when you can achieve the function is okay. And the next here we finished this, and then the next we can add this to these 3 layers to spherical scene. Here we can see this is spherical scene, simulated the Earth, and then here we can jump to the layer. Here we can see these layers are also displayed as 2D layer in this thing. Then the next we are going to stretch this these layers. Here we can see for the buildings, we can go to the style settings. After we open a scene, there are many choices for the scene operations, including the scenes. There are many operations, the style settings, or for the 3D data and the flag manager, and also the 3D analysis. Here we can see there are many 3D spatial analysis provided by SuperMap. And then here we can go to the style settings, extension settings. Your altitude mode, we can change it to absolute or relative to ground. And then here we can see the altitude and the height of the layer. So here we can set a same value for the buildings. So they all look like the same, they all in the same height. Actually, as we know that different, every buildings have its height. So, but here we can check the attribute table. There is no height fields in the table. And what you can you can do is to add new attributes. We can add a height. And apply it. Here we can just see suppose the building's height, just like we can based we can set suppose we can update this building's field like 16 meters. And for these buildings, there is like 100 meters. If you have data with the height, it will be great. Since there is no height information, so here I just support the height of each building. First. We can go back to this 3D scene and the style settings. So here we can see there is a height field we can select. And then if we select this field, the height of buildings will based on the height value we set in the attribute table. So finally, here we can change the foreground color as white to make the we can change all this as white. And the next we can and the texture to the buildings. Here also you can define different features, different textures in the attribute table. So here, after you define the fields, then you can set the texture file. Here you can select the texture file, the texture fields which stores the root of the texture. So here or if you don't have this, you can select the same textures. So let me select this one. And then we can change the timings. Also, all this based on your texture size. So here we can adjust the tiny U and the tiny V. So if you know the floor of the buildings, also here you can set it as the real floor of each buildings. And also the floor information can be also defined in the attribute table. So here I just demonstrated you how to achieve the texture ending. So here then we finished the buildings modeling, and then we are going to do the water. Here also the water we also set to the same. And the height here we can set a little height. The next also we can for the water we are not going to make the extension, but we can set the style of the water by 3D modeling, 3D view. Here we can see there are many styles we can select: still water, slow water, calm neck. Here we can select slow water. Don't worry, we just zoom to layer. And then here we can see the water effect like this. This is slow water. And the next, we can do the road. We also set the style of the road 39. I also shared you the simple resources, including field libraries 3D, nice libraries 3D, and mark libraries 3D. Here you can import the libraries, select the simple resource, and then you can find many subway, square, tube, highway, and apply it. So here we can see the road, and we can do some changes for the road. We can edit the symbol, and then we can here we can see we can and then set the width like 4 meters. For the 3D modeling, it requires a higher performance of your computer. So my computer get stuck. Let me close some. This one. During the waiting time, so here I also want you can take a look at the 3D modeling finished the effect of 3D modeling. So here we can see the tree, the symbol tree. Actually, the cars are all with point data, vector data. So we can symbolize the vector data by 3D symbolization with the car and the trees. And we can see different types of trees and also the fence. The fence. See like this. It is 9. Here we can see the fence is 9 and also the water effect and also the dynamic layer and also the road, the buildings with different textures. Oh, I think it won't be good now. Here I will use this thing to demonstrate you. So as I show you that it is simple. It is simple for you to make 3D modeling. Just the one method is to make extension of the vector data, and the second way is to use this 3D symbol to symbolize the 2D vector data. So only with these two methods you can get a beautiful and vivid 3D scene. So after this scene 3D scene make, we can do the further 3D spatial analysis. Before the 3D modeling, here we can see that the buildings also the 2D data. So here we need to convert the buildings to the model data set. And also convert the building to the model data set. I think there are some mistake in my side, and the texture haven't been added to the layer. Just here, I just show you how to achieve this 3D modeling. Here you can find this 3D analysis, just like the view shared analysis. Then here we can set a point, a viewpoint, and do the view shared analysis. So here we can easily need to know from this viewpoint, we can know which areas are available and which areas are invisible. And the same with the visibility and analysis. We can set one point and set another point. So here we can see if this line is green, it means these 2 points can be is visible. And if here we can just see that to this here, that means this part is visible and this part is invisible. So this is visibility analysis, and we can do many other analysis just like the shadow analysis. Here we can draw a polygon, we can draw area. Then we can get the day-night rate. So here we can much more sampling. The next slide we can see much more. It will be like this. And we can also do other, if you have terrain data, you can do the slope and aspect analysis, isoline analysis, and flooding analysis, and others. And furthermore, these things can be published to the server and do the further application on the website or mobile side. So all these functions need you to dig how to use in your applications. Then so this also is the extension work for you to make a 3D thing and a 3D analysis. I think that's all for that's all the contents for the training. And also yes, and also I want to share talk about these assignments. So here I already published the assignments on the Google Classroom. So here you should pay attention to finish the goals and finish also the extension is optional, but we hope you can finish it. You can have a try after our training, and then you after you finish your work, you can submit your work to the Google Classroom, and also you can submit your work through EVLE. Also, if you can't log in Google Classroom or EVLE, you can email to me and send your final work to my email. Here is my email. And here is the materials I uploaded. I already uploaded to the Google Drive. You can download it and following the tutorials to finish the homework. Such as the spatial statistical analysis and the extension, the network analysis, 3D modeling. And after the training, I will also upload the PowerPoint, the slides to the Google Drive, so you can also refer to it. So I think that's all for my training. Thank you.